In this lesson, we're going to discuss inequalities that can be set up to help us find information about side lengths and angle measures within two different triangles. So we're going to start by looking at the theorem, and this theorem is very wordy. There's a whole lot of words here. So let's just try to pick up what it's saying. So it says if two sides of one triangle are congruent, so we have two sets of congruent sides within these two different triangles. So if two sets of sides of one triangle are congruent to two sides of another triangle, and the included angle, so that's talking about the angle that is in between them. So we're looking at those two sides and the included angle. So, and the included angle in the first triangle is larger than the included angle of the second triangle. So if angle 1, and I'm going to start putting the little slash symbol through it so that I can clarify between the angle symbol and this greater than or less than sign I'm about to use. So if the included angle of the first triangle is larger, so greater than, the included angle of the second triangle, then the side opposite the angle in the first triangle is larger than the side opposite the angle in the second triangle. So if the measure of angle 1 is greater than the measure of angle 2, then the side opposite, A, would be greater than the side opposite of angle 2, which would be B. So all of those words say this. If the hinge theorem works, because the angle is the hinge, and these two sides that are around it are congruent to sides in the other triangle. If the angle in one triangle is larger than the angle in the other one, then the side opposite of that angle will be larger than the side opposite of the other. So the other is the converse, which is just going to go the other way. So if two sides of one triangle are congruent to two sides of another triangle, so we're just going to mark those, and the third side of the first triangle is longer than the third side of the second triangle. So this one starts with if A is greater than B, then the included angle on the first triangle is larger than the included angle of the second. So if A is greater than B, then the measure of angle 1 is greater than the measure of angle 2. So the hinge theorem and the hinge converse allow us to make assumptions, or not really assumptions, but valid arguments about the side lengths or angle measures based on what we start with. So we're going to fill in the blank with greater than, less than, or equal to based on the information that we're given. So the important thing is to figure out where the hinge is. So the hinge is going to be where those two sides meet. So the angle we're talking about here is this 105-degree angle in the first triangle. And if I look at where the hinge is in the second triangle, it is this angle at angle F. So to figure out this relationship, we're going to look at the relationship of the two angles that we have. So the measure of angle C is 105, and the measure of angle F is 110 degrees. So the measure of angle F is greater than the measure of angle C. So the side opposite, so opposite of C, is segment AB. So segment AB will be less than, or just the measure, sorry, I don't need that segment. The measure of segment AB is going to be less than the measure of segment DE. So because of the relationship between the angles, AB will be less than DE. Since the angle's smaller, that side's going to have to be a little bit shorter. All right, looking at our next one. So we're going to figure out where the hinge is by looking at those two sides. So the angle that we're talking about is the one where those two sides meet. All right, so here those two angles are angle H and angle N. So I'm going to look at the relationship between H and N. So H is 117, N is also 117. So since those angles are equal, the sides opposite, FG and LM, are also going to be equal. So it's going to match whatever that angle relationship was. All right, in this one, we're going to figure out some information about angle 1 and angle 2. So here, we're given the opposite side. So if I look at this one, the side opposite of angle 1 is 7. The side opposite of angle 2 is 8. So since 7 is less than 8, the measure of angle 1 will be less than the measure of angle 2. So we are comparing the information that we have. In that one we had side lengths. All right, so if we're comparing angle 1 and angle 2 again, the information that we have is the side length. So 6 is the side length across from angle 1, 6 is the side length across from angle 2, and those are equal. So since the side lengths are the same, the measure of those angles, because it's our hinge, here's our side length, and then we have reflexive property here. So that'll be congruent in both of them. All right, so since those are equal, the measure of the angles across from them will also be equal. So the measure of angle 1 will equal the measure of angle 2. All right, same thing's happening here with our hinge. So I've got this side that's congruent in each, but then I have a shared side. So that one is the reflexive property. And then we're looking at those angles within. So if I'm looking at this 95-degree angle, that's across from NS, or MS. So 95 is across from MS. 98 is across from LS. So since 95 is less than 98, MS will be less than LS. All right, and our final one here, we have the reflexive property for this second side. And then our hinge theorem is talking about across from those angles. So across from angle 1, we have 8. So 8 and the measure of angle 1 are connected. 7 and the measure of angle 2 are connected. And so since 8 is greater than 7, the measure of angle 1 will be greater than the measure of angle 2. So that's the application of the hinge theorem and the hinge theorem converse in terms of how we can use this to set up inequalities or relationships between those angle measures. So next we're going to use an inequality to describe a restriction on x as determined by the hinge theorem or the hinge converse. So what we look at is here we're going to be using expressions instead of just letters and names and such. So I find where my congruent sides are. So this side that's 6 is going to be congruent to the other side that's 6. And then I have a shared side, so that's my reflexive property. So that will be the hinge of the hinge theorem. So based on this, let's look at the numbers that we know. So the 65 degrees is across from the 7. And the 70 degrees is across from the x. So this is going to help me set up my inequality. So since 65 is less than 70, 7 is going to be less than x. So when we are writing an inequality, I want to write it to where the variable comes first. So I'm going to start with the x here. And since this inequality sign opens up to the x, whenever I flip it around, it's still got to open up to the x. So this is going to be x is greater than 7. That's my restriction. So that's what it means by a restriction on x. That means to write an inequality to describe numbers that would work. So as long as x is longer than 7, it goes by the hinge theorem. All right, so looking at this next one, I have my congruent sides. And then I notice a shared side, so that's going to be congruent to itself. So here is my hinge angles. So I've got the 30-degree angle and the 38-degree angle. So to help me set this up, the 30-degree angle is across from 3x plus 2, and the 38-degree angle is across from 12x minus 7. So since 30 degrees is less than 38 degrees, 3x plus 2 will be less than 12x minus 7. We're going to solve this equation, and solving inequalities works the same way as solving equations. It's just that if you multiply or divide by a negative number, the inequality has to switch directions. All right, so we follow our steps just like we would for solving a multi-step equation. So I can move anything. I'm going to choose to move this 3x first. So I'm going to subtract 3x from both sides. That's going to keep my coefficient positive so that I don't have to worry about that extra rule of dividing by a negative. So I have positive 2 is less than 9x minus 7. So I'm going to add 7 to both sides. And I have that 9 is less than 9x. Divide both sides by 9. And I get that x, or 1 is less than x. So to write my solution to an inequality, I want to write the x first. On this one, the x the sign opens to the x, so it's going to be x is greater than 1. All right, so that's what it means by write a restriction on x. That means an inequality. All right, for our last example here, we have in triangle ABC and triangle DEF, and then it's given me like different information. So before I start anything, I'm going to draw two triangles. So I've got ABC, and I'm just using this for markings. And then I have triangle DEF. Right, so DEF. So I just draw any two arbitrary triangles, and it's going to be based off of these markings that I put on it. So it says that AC is congruent to DF, and BC is congruent to EF. So I can tell that the hinge that I'm working with here is the angle that goes between those two congruent sides. All right. Next, it tells me that the length of AB is 11 inches. The length of ED is 15 inches. And the measure of angle F is 58 degrees. So which of the following is a possible... Oh, it says angle F. This should be angle C. All right, so which of these is a possible measure for angle C? So let's just use C as this inequality here. All right, so if I set this up, the 11 is across from C, and the 15 is across from 58 degrees. So if I'm comparing this, 11 is less than 15, so C has to be less than 58. So if I'm looking at this, we have three options here. The only one of these options that is less than 58 is 45. So since the measure of C has to be less than 58 because 11 is less than 15, that is the only possible